Dr. Pedros.
Dr. Nada.
Dr. Justin.
Dr. Blake, Dr. Eric.
Dr. Noah.
And I'm the patient, Gloria.
What is the problem, Gloria?
I have day blindness, so I wear sunglasses even indoors, but not at night. I squint my eyes, and they sometimes shake because I'm very sensitive to light. This is what I usually see, and this is what I see when I'm squinting.
This is what a normal person sees. Considering, I believe it must be achromatopsia.
Are you sure, Dr. Nara? Because achromatopsia is a really rare eye disorder where the patient has some or no common cells that work at all. And in the U.S., only 1 in 33,000 people have achromatopsia.
Oh yeah, my cousin in Florida has achromatopsia too. He wears red-tipped sunglasses to help filter out sunlight. He also uses larger font sizes to help him read. These improvements can only help ease the symptoms of achromatopsia, but they don't cure it.
Yeah, remember when we visited Dr. Lau, an ophthalmologist, and Dr. Studebaker, an optometrist? They both said that there is no cure to achromatopsia, but research is taking place around the world.
We did extensive research on achromatopsia from scientific journals, medical books, websites, and magazines. We also had a video conference and a phone conference with two bioengineers, Dr. Kukusa and Dr. Boson, on current research.
What help can I get now? Can you tell me more about the latest research?
There is gene therapy, bionic eye implants, and stem cell research. We are researching the bionic eye approach.
Let me explain. An image is projected upside down onto the back of the eye, onto the retina. The retina is made of 3 sensory neuron cell layers.
They are photoreceptor, bipolar, and ganglion cells. Photoreceptor cells are known as cone cells and rod cells. They have a diameter of 5 micrometers, and about 10 can fit across a single hair.
The photoreceptor cells convert light energy into electrical impulses. The electrical impulses send through the neuron cells into the optical nerve at the back of the brain.
This is a picture of my retina from Dr. Studebaker's office. This is where the cones are, and this here is Gloria's retina scan, and that's where the cone should be. But there's
A bionic eye implant, a product of current research, replaces defective cone cells in the photoreceptor area. This is a model of a current bionic eye implant. It contains 1,500 photodiodes within the area of a pencil eraser. The photodiodes convert light energy into electrical impulses that are sent to the brain.
There's approximately 200 cone cells in a photodiode. Since there's a number of cone cells in a photodiode, the resolution of an image will decrease, and the image will be more pixelized.
It's good that I can actually see, but everything will be blurry, and there won't be any details.
Don't worry, we've been working on an innovative solution to solve this problem. It's called the HDE, the High Definition Eye.
Based on past FLL seasons, we learned about nanotechnology. We can improve the bionic eye implant with something very small, carbon nanotube. Carbon nanotube is 10 nanometers in diameter and can replace photodiodes in an implant.
Due to the unique electrical, mechanical, and physical properties of the carbon nanotube, they can be modified into different applications. For our innovative solution, we will develop a carbon nanotube to act like a cone cell, or photodiodes.
Even though 40 photodiodes is the same size as the tip of a pencil, we can easily fit over 500,000 nanotubes into each photodiode. Likewise, we can replace one cone cell with 500 nanotubes. Since there will be more nanotubes per cone cell, the resolution will increase. The image the person will see will have more detail than the normal eye.
So I'll be able to see better than the normal person with the implant? Can I have the HDE surgery now?
Well, this solution is still in a research state. Maybe in 10 years, the research will improve and the cost will go down. By that time, our innovative solution should help cure other retina-related blindnesses, such as macular degeneration, retinal pigmentosa, and glaucoma.
10 years later. Congratulations, Gloria. Victoria. You have the first high-definition eye in the world.
I can see all the colors in the rainbow thanks to HDE. Wait, you guys look awfully unneeding surgeons. I can see clearly now, the cones are here. I can see
All the colors in my way. Gone are the dark clouds that had me blind. It's gonna be a bright,
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 sunshiny day.
Very good, very good. Is this a new technology, or is this an idea you came up with yourselves? Is someone working on this? No?
The bionic eye, where with a artificial retina which bypasses where the cones were, that's already being developed but not necessarily in use right now. And there's other research like that going on. But the idea that we use nanocones instead of the photodiodes is our idea.
Yeah, like we said, one of those bionic eye implants, they're fairly large, and they've got photodiodes per like 200 cone cells. So the cone cells will pick up a more smooth image, while these are more pixelized.
Have you shared this research or this idea with anyone?
We shared it to Dr. Studebaker and Dr. Kukuza and Dr. Burson with this. And they are the, two of them are bioengineers, and Dr. Studebaker is the ophthalmologist.
Have you shared it with anybody in your community or your school, parents, anything like that?
Yes, we have. I've shared it with my cousins, and I think Justin shared it with his school.
Yeah, we all told our parents about it and our friends.
Do you guys see any potential issues that could come from this?
Like we said, right now the research is not available for this, which is why we said 10 years later the research and the cost will go down. Or the research will get better and the cost will go down.
And also, right now, one of our major issues that we've been trying to figure out would be how to get enough electrical impulses through that without frying the nerves underneath. So we've been working on how to figure that out.
And the cost of the carbon nanotubes
Yeah.
is super expensive right now.
Yeah, at the moment it's like 6 million.
Yeah, just for like an inch.
Right.
It's a square inch.
Did you explore any other options or any other solutions to this problem?
Yeah, we looked at a literal bionic eye where you kind of transplant the eye, transplant with a different eye.
When we were really just starting, we all did research to find the project that we're going to do, and one of us, this is the one we chose, but it's not the exact what we had now, because it was a headset with cameras on it, and then the cameras would send the information to the brain, and so we changed that and made it better.
We would have her wear a pair of glasses and have an eye or a camera on it, and then it would display on the monitor.
I saw the photo in here.
Yes, that's exactly what it is.
How did you decide that this was the problem that you guys wanted to work on?
We based on we got each like remote or two on all of our on whatever we picked, so that's what determined.
As I believe one of the other doctors has said, we all went out and said, okay, I'm going to look at this, I'll look at VADs, I'll study the 400, vision headset, and then once we gathered enough information, we went back to our team. It's like, I was looking at the VAD, and this is what we could do with it. And then once we had a list of everyone's topic that they had chosen, we then decided to vote on which one we thought we really want to do as a group.
We also researched different solutions like gene therapy, stem cell research.
Those are the other researches currently for blindnesses, related blindnesses.
I don't think so.
Thank you very much. Good presentation.
You like some Lego candy?
Sure, thank you. Good luck today. And have fun.
You guys can keep the book till the end of the
Okay.
Okay.
All right. You can probably return here if you want to have it back by probably by about 10:30 or 11 minutes. Okay. Right after the opening ceremonies would probably be fine. Okay.
Thank you.
Thank you. Good job. You did a good job.
Thank you.
So have a good day.
You too.
Let's change it.
We go to the next.
Discovery B is around the corner.
That's right.